Let's come to a very interesting thing, the minimum frequency. To find minimum frequency, we need to find T max. Let's see how do we find that. Let's take case 2. Now case 2 is a case when phi is equal to 0, which means phi bar is equal to 1. When phi is equal to 0, and presuming that initially there is an internal capacitor here, right? This input would have been 1, so this would have got charged to 1 when phi was equal to 1. It's a pass transistor. And now phi has gone to 0. So when phi has gone to 0, technically this value should be able to hold it to a logic value 1. But does that happen? When this transistor turns off, we know that there are leakage currents. We have already seen the concept of charge leakage, due to which the capacitor charge or the charge present on this capacitor will tend to lose its value. So till what time will the correct value be hold at this point, and because of this point at this point also? We have already seen this, that initially say the voltage is high, when the transistor turns off in charge leakage the voltage keeps on going down, and it can hold the value up till say this point, which is nothing but my hold time. So let's say that if my T by 2 goes beyond the hold time, so till this time if its T by 2 max is there, it will still have the correct value. But if it goes beyond the hold time, just at hold time or beyond it, it will lose its value, which we have already seen in the explanation of charge leakage. So what is the maximum time my phi can be equal to 0 for? Is nothing but hold time. So my phi can be 0 till this point of time. If my phi is 0 anytime beyond this, my circuit will lose its value because of the problem called as charge leakage. So the maximum time which my T by 2 max can be 0 for is nothing but TH, which is also nothing but T equal to, or T max equal to twice TH, which gives us minimum frequency, because F is inversely proportional to T, as 1 by twice TH, and anything below this frequency will lead to a corrupt value, because my value would be lost due to charge leakage. So this is also the refresh mechanism which we use in DRAM. This is the frequency of my operation, and this is the whole time where you keep on refreshing your circuit after this much time again and again to ensure that your value is not lost. I can see still some people are confused about what's happened when phi is equal to 0. So I'm just going to recap this real quick. When phi is equal to 0, M1 is off. In simple words, the output of M1 and inverter 1 output should be able to hold its previous value. However, what happens is when M1 is off, because of the problem called as charge leakage, which we have discussed in details previously, the output of my pass transistor tends to lose its charge, because there's a capacitor present here internally. It tends to lose its charge, and the voltage across that capacitor, say let's presume initially was a logic high, it keeps on faltering, which we have seen in the charge leakage problem, and at one point of time it will go beyond Vx, so that it will be interpreted as an incorrect value. And at this point of time where the value is equal to Vx is nothing but my hold time. So the maximum amount of time for which my phi can be equal to 0 is nothing but hold time, and anything beyond this the value would be lost. That is what I have written. T by 2 max is nothing but hold time, which gives us the minimum frequency, which is also nothing but the refresh frequency of my circuit. So this is just the basic of how do you find minimum and the maximum clock frequency. And you need to understand that your clock cannot go above the maximum frequency, because the circuit will not have enough time to complete its computation. They are based in how we can make this further faster, which is currently beyond the scope. And your circuit cannot go below the minimum frequency. If that happens, your value would be corrupted due to a problem called as charge leakage. And this is going to be a very important phenomena when we study DRAM. Hope you have followed. Stay tuned for further clips, and thank you very much.